Hello everyone, happy to see you here, welcome back to my channel. Hi, I'm Mathematics. Today we have really interesting exponential equation from entrance examination. We have 3 to the power n plus 2 to the power n equal to 35. If you have your answer, your solution, you can also write your solution down into the comment section and then we will check our answers. Okay, so right now let's start. First of all, let's do the next trick. Instead of this 3 to the n, let's write 3 to the power n raised to the first power. Okay, it changed nothing because this is our first power, and instead of this 2 to the power n, let's do the same thing. So we have plus, we have 2 to the power n raised to the first power equal to 35. Right now, instead of this 1, let's write 3 over 3. Very tricky move. So we have 1. Instead of this 1, let's write this fraction 3 over 3. It changed nothing because 3 over 3 equal to 1. So let's do the thing right now. So this is our first step, this is our second step. So as a result, what do we have? We have 3 to the power n raised to the power 3 over 3, and we have plus 2 to the power n raised to the power 3 over 3 equal to 35. Okay, I hope you understand this step. We just raised it to the power 1, and in this case we raised to the power 3 over 3. It changed nothing. Right now, a very tricky move. Instead of this 3 over 3, we can easily split it by two parts. So we can write it as a product, 1 over 3 times 3. So instead of this 3 over 3, let's write this product. Let's do the thing right now. So as a result, we have 3 to the power n raised to the power 1 over 3 times 3, and we have plus 2 to the power n raised to the power 1 over 3 times 3 equal to 35. So I hope you understand this step. What we're going to do next? Right now we need to know a really great rule. Someone called this as rule of interchange. So this rule looks like that. When we have a to the power m raised to the power n, we can write it as a to the power m times n. And in this case, let's write this 1 over 3, let's multiply it by n. We can easily do this. So 1 over 3, we're going to multiply by n according to this rule of interchange. So as a result, what do we have right here? We have 3 to the power n over 3 raised to the power 3, and we have plus 2 to the power n over 3 because we multiply n times 1 over 3, and raised to the power 3 equal to 35. Okay, I hope you understand this step. Right now, if you look closely, we have a sum of two cubes, but with one really interesting tricky move. We need to write our substitution. So let our 3 to the power n over 3 is equal to, let's go with, for example, our x. So this is our x, and in the same way, 2 to the power n over 3 equal to our y. So as a result, what do we have right here? We have x cubed plus y cubed according to our substitution. Okay, so let's do this right now. So we have x cubed plus y cubed and equal to 35. From school, we need to know this formula. We have a sum of two cubes. So right now, let's write our formula. If we are talking about our school identity, we have a cubed plus b cubed equal to we have a plus b right here. So we have a plus b, and in another parenthesis we have a square minus ab and plus b square. Okay, this is our formula, and right now let's apply this formula right here. We have a sum of two cubes, absolutely the same thing, but with x and y. So as a result, what do we have right here? We have x plus y, and in another parenthesis we have x square minus xy and plus y square equal to 35. Okay, so I hope you understand this step. Right now, a very tricky move. We have a product of two parentheses, and there is one really interesting identity in terms of math, because this parenthesis is less than this one. Okay, so x plus y is less than x square minus xy and plus y square. Okay, these are our identity from school. I don't want to prove it, but I hope you understand it. I hope you understand my logic. This expression doesn't matter x and y, doesn't matter whatever we have values x and y. X plus y is less than x square minus xy plus y square. What it tells us? It tells us that this parenthesis is less than this one. But right now, let's look closely. What do we have on the right side? On the right side, we have 35. So how can we express this 35? In two cases, 1 times 35, and the next one is 5 times 7. And according to this identity, according to this inequality, we are talking about this parenthesis equal to 1 or 5, and this parenthesis equal to 35 or 7. So this is our first case. We need to check it, what will happen in our first case. And we have the second case. So right now, let's start with the first case. So this is our first case. This is our first case. This parenthesis is less than this one, so x plus y equal to 1. Yeah, so let's write it. So we have let's write our full equation. So we have x plus y times x squared minus xy and plus y squared equal to 1 times 35. From here, this one is less than this one, so x plus y equal to 1, and this parenthesis equal to 35. So right now, let's solve our first case. So we have x plus y equal to 1, and we have the second, and we have right here the second, x squared minus xy. So we have x squared minus xy and plus y squared equal to 35. Right now, how can I solve this equation? Let's raise this on the left side. Let's raise to the first power. Let's to the second power. Let's square both sides, sorry, yeah? So we have right here x plus y to the second power equal to 1 square. As a result, we have x squared plus 2xy and plus y squared equal to 1. And right now, let's write this expression right here under this expression on the right side. So minus, let's subtract this expression. So we have x squared plus 2xy and plus y squared equal to 1. So from here, what do we have? We cancel this x squared, y squared, and y squared. We have minus xy minus 2xy. So as a result, we have minus 3xy equal to 35 minus 1. We have 34. So from here, our xy is equal to minus 34 over 3. So it tells us that the product, we're talking about integers, yeah? So when we're talking about integers, it cannot be real in terms of like negative sign and in terms of this 3 in our denominator. So we reject this first case. So this is our rejected case. Okay, so I hope you understand it, why we reject this first case. Right now, let's solve our second case when the sum x plus y equal to 5 and this parenthesis equal to 7. So right now, let's solve this second case. Okay, so second case is right here, x plus y times this parenthesis equal to 5 times 7. And as I told before, this parenthesis is less than this one, so x plus y equal to 5. So let's write this first equation, x plus y equal to 5. And we have the second parenthesis, x squared minus xy and plus y squared is equal to 7. Okay, is equal to 7. Right now, how can we solve this equation? Absolutely with the same algorithm. Let's square both sides in this first equation. So as a result, we have x plus y. We squared our left side equal to 5 square. Okay, and as a result, what do we have right here? X squared. We have plus 2xy plus y squared equal to 25. And right now, let's plug in this, let's subtract from this one, let's subtract this second equation. So as a result, we write under this one, we write this equation. So we have x squared plus 2xy plus y squared equal to 25. Okay, and when we subtract it, we have one really interesting moment. So we have x squared, we cancel, right here we cancel y squared, and as a result, minus xy minus 2xy, we have minus 3xy, and right here on the right side, we have minus 18, and as a result, when we divide both sides by minus 3, we have that xy is equal to 6. And this is a really great expression for us because in the previous case we had a negative expression in terms of integers. It's not real. So right here we have a positive and we have integers. So everything is really great. And right now let's solve our final equation. So in the beginning we had that our x plus y equal to 5. So this looks like final step. So we have this our x plus y equal to 5, and we have a product xy equal to 6. So let's solve this final system of equations. So we have xy equal to 6. How can we solve it? Of course, let's express from here our y, for example. So y equal to 5 minus x, and let's plug in this y instead of this y right here, okay? As a result, what do we have right here? We have x times 5 minus x, 5 minus x equal to 6, okay? Equal to 6. We plug in this in the second equation. What do we have right here? We have, looks like a quadratic equation, so let's do this. So we have 5x minus x squared equal to 6. Let's change in order a little bit because it looks like the quadratic equation. We need to change in order. As a result, we have minus x squared plus 5x and minus 6 equal to 0. Let's multiply both sides by minus 1 because we prefer, right here, we prefer a positive sign. So as a result, we have x squared minus 5x and plus 6 is equal to 0. We can easily solve it with a discriminant, but I'm going to show you a really great tricky move right here. Instead of this 5x, let's write 2x plus 3x, okay? So we can write it as x squared. We have right here minus. Instead of this 5x, let's write 2x plus 3x, okay? Plus 3x, and plus 6 is equal to 0. From here, we have x squared minus 2x minus 3x plus 6 is equal to 0, and let's factor. From here, let's factor x in these two values, and from this expression on the right side, let's factor as well. Let's factor our 3. So as a result, what do we have right here? We have our x, and in parentheses we have x minus 2, and right here we have minus. Let's factor from here our 3, and in parentheses we have x minus 2 as well. X minus 2. Right now we have x minus 2 right here, we have x minus 2 right here, so let's factor our x minus 2. Okay, so we have right here x minus 2, and right here we have x minus 3. Okay, x minus 3 is equal to 0. So right now we're going to consider it as a two solutions right here. So x minus 2 is equal to 0, or x minus 3 is equal to 0. From here, x first is equal to 2, and from here we have x second is equal to 3. So we have two x's. First one, x first equal to 2, and the second one, x second equal to 3. But let's write our really important equation. So but in the beginning of this system of equation, we have that our y equal to 5 minus x. Okay, so we're going to consider it as a two pairs of solution. So if x first equal to 2, then y first equal to 5 minus 2 equal to 3. So y first is equal to 3. And right here, if x second equal to 3, then y second equal to 5 minus 3 equal to 2. So we have y second equal to 2. So we are talking about two pairs of solutions. So this one, so we have xy equal to, the first pair we have 2, 3, and the second pair we have 3 and 2. But just keep in mind that in the beginning we had n, so we need to recall our substitution. So let's recall right here that our x is equal to 3 to the power n over 3, and our y is equal to 2 to the power n over 3. This is our substitution, don't forget about it. So we have right here two cases. We have, let's consider the first pair. So the first pair right here, the first case, 2 and 3. When we consider 2 and 3, we're talking about x equal to 2, y equal to 3. So x equal to 2, y equal to 3. 3 to the power n over 3, we have right here. 3 to the power n over 3 is equal to 2. And we have y, we have 2 to the power n over 3 equal to y equal to 3. And if you look closely, we don't have the same basis. So we have different bases. So right here we don't have, like right here we have no integer solution. Second case, we have the pair 3 and 2. This is our 3 and 2. So we have right here, as a result, we have not x, like we have 3 to the power n over 3. 3 to the power n over 3 is equal to 3. Yeah, and we have right here 2 to the power n over 3. 2 to the power n over 3 is equal to 2. So as a result, right here, n over 3 equal to 1. Yeah, we have n over 3 equal to 1. And from here, our n is equal to 3. So from here, our n is equal to 3. And right here, we have absolutely the same thing. N over 3 is equal to 1. And from here, n is equal to 3. Okay, so I hope you understand it. We find our integer solution, but in the end, let's check our solution. Let's check it. Let's see a graph. Right now we can see a graph to this question. You can see that 1 point of you can see this, I'm not sure how many points of intersection, but we have this n is equal to 3. Let's check it. Let's prove. Okay, let's prove it. As a result, what do we have right here? We have right here 3 to the power n plus 2 to the power n is equal to 35. So as a result, we have 3 to the power 3 plus 2 to the power 3 is equal to 35. And I guess this is a correct expression. We have 27 plus 8, which is equal to 35. Everything is correct. So I hope you understand my explanation. Let's write our final answer. I don't have enough space right here, so let's write it on the left side right here. So answer n is equal to 3, n equal to 3. You see a graph to this question, so I hope you understand this challenge. Thank you everyone for your time. Write your question down into the comment section. Write your notes about this question. This question looks like a very easy challenge because I guess a lot of students can solve it by inspection, but as you can see, a lot of really interesting tricky moves, a lot of really interesting solutions, so I hope you understand it. I hope you enjoy it. Thank you everyone for your time. See you in the next videos and have a great day.